Hello students. Today, we are going to solve a problem from the Pinsky collection. Let's read the problem statement together. Two particles move along the x-axis uniformly with speeds v1 equals 8 meters per second and v2 equals 4 meters per second. At the initial moment, the first point was 21 meters to the left of the origin and the second 7 meters to the right of the origin. When will the first point catch up with the second? Where will this take place? Plot the graph of the motion. As you can see in the diagram, we have two particles, P1 and P2. P1 starts at position -21 on the x-axis and moves to the right at 8 meters per second. P2 starts at position +7 and moves to the right at 4 meters per second. Since the first particle is faster, it will eventually catch up to the second. Let's work through. Pause the video a bit and try this question. We will look at how to solve the problem using a relative velocity approach. Let's solve this by taking the second particle as our reference frame. This means we will analyze the motion as if the second particle is standing still and the first particle is moving relative to it. The velocity of the first particle relative to the second particle, denoted as v12, is the difference between their velocities. We can express this with the equation v12 equals v1 minus v2. Plugging in our values from the previous problem, we have v12 equals 8 minus 4. This gives us a relative velocity of v12 equals 4 meters per second. As you can see in the diagram, by using this reference frame, we simplify the problem to finding how long it takes for the first particle to cover the initial separation distance at this new relative speed. From the perspective of the second particle, the first particle is approaching at a speed of 4 meters per second. Next, we determine how far apart the two particles are at the start. The initial position of the first particle is x10 equals -21 meters, and the initial position of the second particle is x20 equals 7 meters. The initial separation distance, d, is the difference between their starting positions. We calculate this as d equals x20 minus x10. Substituting our values, we get d equals 7 minus -21. This simplifies to an initial separation distance of d equals 28 meters. The first particle has to cover a relative distance of 28 meters to catch up to the second particle. Since we are treating the second particle as stationary in our reference frame, we can find the time, t, it takes for the first particle to cover the 28-meter gap at its relative speed of 4 meters per second. We use the formula, t equals d divided by v12. Substituting our known values, we have t equals 28 divided by 4. This gives us a time of t equals 7 seconds. Therefore, the first particle will catch up with the second in exactly 7 seconds. Alright class, let's determine exactly where this meeting happens on the x-axis to find out where this takes place on the actual x-axis, which is the ground reference frame. We take the time we just found, t equals 7 seconds, and see how far one of the particles has traveled in reality. Let's use the second particle for this calculation. We know its initial position was x20 equals 7 meters. Its velocity is v2 equals 4 meters per second, and it travels for a time of t equals 7 seconds. Using the equation of motion for constant velocity, x equals x to 0 plus open parenthesis v2 times t close parenthesis, we plug in our values, x equals 7 plus open parenthesis 4 times 7 close parenthesis. Simplifying this, we get x equals 7 plus 28, which results in a final position of x equals 35 meters. So, the particles will meet at a position 35 meters to the right of the origin. That concludes our lesson for today. Thank you for watching. This content is brought to you by the Ekalavya Educational Channel. Remember to keep learning and keep growing. If you found this helpful,